So in this video, we will discuss about your maximum power transfer. So your maximum power transfer is the main application of your both Thevenin and Norton theorem. So if you notice that if you have an equivalent circuit for your, let's say, your Thevenin equivalent circuit will have our VTH, and then you have your RTH, then your RL. Take note that your RL is the load in this circuit. Your RL, your R load is the load in the circuit. So when you're talking about your maximum power transfer, you are talking about the maximum power that can be transferred to your load. So take note that your RTH is the Thevenin resistance, or the Thevenin, or the resistance of the circuit, or it represents the characteristic of the whole circuit, that is your RTH and your VTH. So in order to get the maximum power transfer, so we need to get the value or the power at RL. So it means that the maximum power transfer is the maximum power that is delivered to your load RL. So our maximum power is can be the power of RL can be solved using P is equal to, so it's either V squared over RL or our VTH VRL squared over RL, or it's also equal to IRL squared multiplied by RL. Take note that your IRL is equal to ITH, which is also equal to our short circuit current or your Norton current, which is just equal to our VTH divided by RTH plus RL. So why? Basically because this is just a series connected circuit. So we discussed in the book that the formula for your Pmax is equal to VTH squared, VTH squared, or over your for RTH. So paano nangyari yan? So this derivation of the formula will give you the definition of the maximum power transfer, wherein in order to have a maximum power transfer, your RTH must be equal to your RL. Kumbaga, at RTH, where your RTH is equal to your RL, nagkakaroon ng maximum power transfer sa RL mo. So, in order to prove this one, let us use this equation. So, since P is equal to I squared RL and our RL is equal to this VTH over RL, so therefore I may say that my P is equal to VTH or over RTH plus my RL squared multiplied by our RL. Take note that your RL is a variable load, which means that it changes. And your RTH is the characteristic of the circuit, and your VTH is also a characteristic of the circuit. So therefore, these are constants. So in order to get the value of your Pmax, we learned that you will get the derivative of your P with respect to your variable RL, dRL, and then we will let this value equal to 0 in order to get their maximum power transfer, right? So therefore, let us differentiate your power with respect to RL. So differentiating your dP over RL with respect to RL, so we have the derivative of your VTH squared all over RTH plus RL, so squared dyan with respect to our RL. Okay? And multiplied by our RL syempre. Okay? So since our VTH is constant, pwede natin siyang ilabas. So VTH squared, okay, times the derivative of your RL divided by RTH plus RL squared with respect to our RL. Okay? So differentiating this one, we'll see that we will have a value equal to VTH squared multiplied by the derivative of RL. So the derivative of our RTH plus RL, pwede kong itaas yung square mo dito sa negative 2 multiplied by RL with respect to our DRL. So you've learned in your calculus that the derivative of UV with respect to dx is just equal to u dv over dx plus v d over dx. Okay, so therefore we have VTH squared multiplies, let this equation be, let this term be your u and let this term be your v. So we have RL, u muna tayo, so we have RTH plus RL raised to negative 2 times the derivative of our RL or your v, right, plus the derivative plus our RL multiplied by the derivative of our u, which is the derivative of RTH plus RL raised to negative 2 with respect to our DRL. So with respect to our DRL, so the derivative of RL is just equal to 1. So we have VTH squared multiplied by RTH plus RL times negative 2, and the derivative of RL is equal to 1, right? So plus RL multiplied by the derivative of this term, so we have a value equal to the derivative of negative 2 multiplied by RTH plus RL multiplied by raised to negative 2 minus 1, so we have negative 3 times the derivative of our RTH plus RL with respect to the RL. So take note, the derivative of RTH is 0, okay, because your RTH will be considered as constant. So we have this one, okay. So further manipulation of the equation, so we will have your VTH squared multiplied by RTH plus RL raised to negative 2 multiplied by 1 plus our RL multiplied by negative 2 multiplied by our RTH plus RL raised to negative 3, so multiplied by the derivative of RTH, which is 0, plus the derivative of RL is 1, right? So, bakit 0 yung RTH? We defined that your RTH and VTH are constant. So, we have a value later on be equal to VTH squared, okay, times RTH plus RL raised to negative 2 plus negative 2 RL negative 2 RL, so divided by our, so RTH ibababa na natin yung negative 3 nyo plus RL raised to negative 3. So take note that kanina pa pwede natin ibaba to. So we have VTH squared multiplied by 1 all over RTH plus RL squared plus negative 2 RL. So dapat hindi ito negative, ito. Why so big? Kasi binaba na natin, di ba? Yung positive nito dapat. Okay? So, minus 2RL divided by our RTH plus RL raised to 3. So, adding this equation is equal to our dP over dRL. So, we will have a value equal to, so ito yung greatest common factor natin. So, we have VTH squared multiplied by RTH plus RL raised to 3. So we will have a value equal to RTH plus RL squared. So we will have a value equal to RH plus RL. RH plus, kasi pag dinivide mo to, divided by dito, so we have a RH plus RL resistor minus our 2RL. Take note, RL yan. Right? So you'll have a value equal to VTH squared multiplied by RTH plus RL minus 2RL. We have RTH minus RL, tama? Divided by RTH plus RL raised to 3. Take note that in order to get the maximum power transfer, your dP over dR must be equal to 0. So, since dP over dR is equal to 0, so pag nag-cross multiply ako dito, 0 multiplied by RTH plus RL is 0. Cube. 0 divided by VTH squared is 0. So, therefore, we have an equation equal to 0, which is equal to RTH minus RL. So, at maximum power, I may say that your RTH must be equal to your RL. Okay? So, since you already know that your RTH is equal to RL, so therefore, substituting this equation, let's say this will be our equation 2, to our equation P max, equation P. So therefore, we have at P max, your RTH is equal to RL. So therefore, we have our P max is equal to VTH all over RTH plus RTH, since your RL is equal to your RTH, right? Squared multiplied by RL. So therefore, we will have an equation equal to VTH squared all over RTH plus RTH is equal to 2 RTH squared is equal to 4 R RTH squared multiplied by our RL. Take note that our RL, based on our equation or derivation, that at maximum your RTH is equal to RL. So therefore our Pmax is equal to VTH squared all over 4RTH squared, and your RL is equal to RTH, so therefore it is safe to say that it is also equal to RTH. So cancelling your RTH, one of your RTH, so we have VTH squared all over 4RTH, which is equal to your Pmax. Okay, that is our maximum power transfer. That is a formula for our maximum power transfer. Okay, also your RTH is equal to your RN if necessary. Okay, therefore by definition your Pmax is attained when your RTH is equal to your RL, right?